Okay, so today we are going to start talking about musical tones, pitch, timbre, and vibrato. And for music people, you guys are all familiar with these terms, right? Pretty familiar, very good. So it'll just be a very quick review for us all. But I would like to explain these terms in terms of physics rather than music. So the things that we have learned, let's try to relate them to what scientists think about these terms when we look at them. So the first one is spectrum of vibrations. So as we've been talking about, a single frequency is called a simple harmonic motion. Looks like this. And it's called a pure tone. However, the fact that pure tones exist, but they're not really very common, they're actually a mixture of many tones, make sure that we need to understand what is called the spectrum of vibration. So when we were looking at vibrations on a string, we said that if there was standing waves on a string, in musical terms, we call it a harmonic sequence, where in a harmonic sequence, the first note that it can vibrate with, the string can vibrate with, is called a fundamental, and everything else is called the harmonic series. Each harmonic series is related to the fundamental frequency as either 2 times, or 3 times, or 4 times, or 5 times. Sounds are a combination of many, many frequencies. And one of the ways to characterize these combinations is called a pitch. Now, what is the relationship between pitch and frequency? The basic relationship between pitch and frequency is measured and pitch is felt. So the same sound, if we're measuring it with an instrument, it is called a frequency. If we're feeling it, it's called a pitch. So then comes the question of what are some of the rules we have to define for most situations? What is a pitch of a pure tone? A pitch of a pure tone is just a sinusoidal wave. Which corresponds to the frequency of the sound that you're hearing. Number 2, what is the combination of pitches? Like what is the relationship when we talk about harmonic series? When we have more than one tone, but each of those tones is an integral multiple of the fundamental, that is called harmonically related tone. So if your tone has frequencies F1, F2, F3, and each of these is related by, say, F2 equals 2 times F1 and F3 equals 3 times F1, then that is called a harmonic series. The third one is called a complex tone. A complex tone is where all kinds of possibilities exist. We could have cymbals in there doing whatever they want to do. You could have flutes, you could have pianos, you could have all kinds of instruments that are being played together. And not every single one of them can be nicely depicted by a sine curve. Those are called complex tones. And sometimes, for humans, it is very difficult to isolate the pitch of a tone. Do you guys have heard about Fourier Transforms? What they do is they take a complex tone and they put it through what is called a Fourier Transformation device, and it tells you all the frequencies that exist in that. So it gives you numbers of frequencies that exist. So those are the 3 ways we can interpret them. So in a nutshell, we have to relate the frequency of vibration produced to the pitch that we hear. So your hearing is pitch, measuring it on an instrument is frequency. Frequency and pitch are different things. Frequency is objective, scientific, can be measured by the help of instruments, whereas pitch is subjective and it totally depends on the listeners. So two people hearing the same frequency might interpret them differently. That is why you get ear training. Music people, yeah? What do they do when you have ear training?
We essentially learn how to identify relations between pitches.
And there's a correct way to do it and an incorrect way to do it, right? So what you're training actually is not your ear, but in fact your brain to recognize the different series and the different combinations. But the same thing, if you put it through an instrument, it'll tell you, okay, this is the frequency you're hearing. But you are being trained to do that. So what is pitch? So at some point, they decided that they needed to define what a pitch was. So in 1960, they came up with this definition of what a pitch is. And they said it is the attribute of our auditory sensory sensation in terms of which sounds are ordered on the scale from low to high. That's how they defined it. And so what they did was they put it like 100 people or 1,000 people in a room, and they told them, what do you hear? And they marked out, okay, this is high, this is low, this is the pitch we hear, this is the pitch we hear. And because it's so subjective, it has error bars in it when you're talking about pitch. Because everybody hears differently. Everybody's ears are different. Are you old? Are you young? Are you 40? Are you 30? Are you 20? Are you 10? Right? And so there are error bars in this. That's why, do you remember those equal contour curves that we were talking about that everybody hears about this loud for these frequencies? Those also have error bars in them. Okay. Pitch allows sounds to be ordered on a scale based on the frequency and the sound producing object. So according to the American National Standards Institute, pitch is the auditory attribute of sound, according to which sound can be either low or high. But in terms of science, high pitch means more oscillations per second, higher frequency. Low pitch means lower number of cycles per second or a low frequency. And even more interesting, we all have two ears. So it is a possibility, and many people report that if they hear something in their right ear, it sounds different from when they hear it in their left ear. So even a person in isolation may actually tell you two different pitches for the same frequency. And the other thing that pitch is related to, remember when we were talking about the ear, we said that the basilar membrane goes into action with every corresponding frequency that comes in. When you do ear training, do you know what you're doing? You are actually making your brain concentrate as much as possible to make those critical bands as small as possible. So you can actually tell minute differences that normal humans cannot between, say, 512 and 480. To a normal human, if you just present it. Okay, another thing that's very interesting is every human is capable, if you present them with two tones simultaneously, they can tell you that this is higher or lower than the other. What the ear training does is you recognize that tone as being higher or lower than a particular frequency. And then by how much higher or how much lower. If you were presented by 480 and 512, nearly all humans can tell which one is bigger than the other. But here's the thing. Many sounds consist of repeating patterns. So when do we define it as a pulse and when do we define it as a pitch? So scientifically, when the pattern is 12 hertz or less, we don't call them pitches. We call them rhythmic pulses. And when the pattern, the frequency is 20 hertz or more, they actually fuse together and we call that a pitch. And 90% of the people, 15 kilohertz or more, will tell you that they're still perceived as pitches. In other words, a high-pitched sound corresponds to a high frequency, and a low-pitched sound corresponds to a low frequency. So this is a sound wave coming in. If you put a person here, what does the person hear? A pitch. If you put the detector here, what does the detector hear? Frequency. Got it? That is a very simple way of remembering it. So the basic unit for pitch is an octave. An octave is, each octave has how many notes? Big ones, not the half notes. 8. A, B, C, D, E, F, G, and then it goes back to A, right? And then the half notes in the middle. We'll talk about those later, but an octave means 8 notes. And each octave, when they build it, is the ratio 2:1. So if this is like 2, then the next octave up must be 4, and the next octave up will be 8, the next octave up will be 16. So it's 2:1 ratio for going up the ladder and going down the ladder. I really like this last point. It says it's worth noting that sound waves themselves do not have a pitch. They only have oscillations, which means they only have a frequency. What does it take for them to become pitches? Humans.